Welcome to Lesson 3, Ofuka Area 3. In Lessons 1 and 2, we learned how science is applied in agriculture and health. We saw how farmers use scientific thinking to grow better crops. We saw how doctors use scientific thinking to treat diseases. Now, in Lesson 3, we are going to learn how science is applied in industry. We are going to see how manufacturers use scientific thinking to produce better products. We are going to see how they ensure products are safe and reliable. We are going to see how they improve efficiency and reduce costs. By the end of this lesson, you will understand that science is behind every product you use, the clothes you wear, the food you eat, the technology you use. All of these are products of applied science. So let's get started. Let me tell you about quality control in industry. Quality control is a practical application of scientific methods used to ensure that products meet established standards. This is really important because it protects consumers. It ensures that products are safe and reliable. Here is how it works. First, manufacturers use precision and accuracy. Products are carefully measured according to exact specifications. There are minimal tolerances. That means the measurement can only vary by a tiny amount. This ensures consistency. For example, if a pharmaceutical company is making a tablet, each tablet must contain exactly the right amount of active ingredient. If one tablet has too much, it could be dangerous. If one tablet has too little, it won't be effective. So they measure carefully. They use precise instruments. They record exact values. Second, they conduct systematic testing. Testing is done at multiple stages of production. They use standardized procedures. They record results. They identify defects. For example, a food company might test for contamination at different stages of production. They test the raw ingredients. They test during processing. They test the final product. They are not just testing at the end, they are testing throughout. Third, they analyze data. Test results are examined to detect patterns. They trace problems to their causes. They implement effective solutions. For example, if they notice that defects are occurring at a particular stage of production, they investigate that stage. They identify the problem. They fix it. They verify that the fix works. Fourth, they use replication. Quality control procedures are repeated and applied to every product. This maintains uniform standards. Every product is tested. Every product meets the standards. Not just some products, every product. So what is the real world impact? Well, quality control ensures that pharmaceutical products are pure and safe. It ensures that food items are free from contamination. It ensures that manufactured components have the correct dimensions. It ensures that electrical products are safe. The overall impact is the production of safe and reliable goods, improved customer satisfaction, reduced waste, and the production of brand reputation. This is how science protects consumers. This is how science improves manufacturing. Now, let me tell you about process optimization. Process optimization is an important application of scientific methods aimed at improving manufacturing efficiency. Manufacturers want to produce products, more products, faster with less waste and at lower cost. How do they do this? They use science. Here's how it works. First, they use hypothesis testing. Engineers propose ideas about process improvement. They predict which changes will enhance performance. For example, an engineer might hypothesize that changing the temperature of a process will increase production speed. They test this hypothesis. They see if it works. Second, they conduct controlled experiments. This is really important. They alter one variable at a time while keeping other factors constant. For example, if they want to test whether temperature affects production speed, they change the temperature but keep everything else the same, which may include the same equipment, the same materials, the same workers, and the same time period. This allows them to see if the temperature change actually affects production speed. If they change multiple variables at once, they wouldn't know which one caused the difference. Third, they collect and analyze data. Production data is gathered to measure efficiency. They calculate costs. They assess environmental impact. They are using empirical evidence. They are not guessing. They are measuring. They are testing. And they are what? Analyzing. Fourth, they use cumulative knowledge. Findings build on previous research. Best practices are documented. Continuous refinement takes place. They don't start from scratch every time. They learn from past experiences. They use but they improve over time. What is the real world impact? Well, process optimization is used to increase production speed. It is used to reduce material waste. It is used to improve energy efficiency. It is used to lower manufacturing costs. The overall impact is increased productivity, reduced cost, environmental benefits, and a stronger competitive advantage. This is how science makes manufacturing more efficient, and this is how science improves industries. Let me tell you about problem solving in manufacturing. Manufacturing facilities encounter problems all the time. Equipment breaks down, products have defects, production delays occur, worker safety issues arise. So, how do manufacturers solve these problems? They use science. Here's how it works. First, they conduct objective analysis. Problems are examined based on evidence, bias is minimized, root causes are carefully identified. For example, if products are defective, they don't just blame the workers, they investigate. They look at the equipment, they look at the materials, they look at the procedures, they gather evidence, they identify the real cause. They are being objective, they are not making assumptions. They are gathering evidence. Second, they use a systematic approach. They methodically test potential solutions. They evaluate results. They make adjustments where necessary. For example, if they identify that equipment is causing defect, they might test different maintenance procedures. They try one procedure, they measure the results. They try another procedure, they measure the results. Then they compare. They identify which procedure works best. Third, they use replication and verification. Solutions are tested multiple times. Results are confirmed. Consistency is established. For example, if a new maintenance procedure seems to reduce defects, they don't just use it once. They use it multiple times. They verify that it consistently reduces defects. Fourth, they use evidence-based decisions. Decisions are based on data, not on guesses or assumptions. They don't just do what they think might work. They do what the data shows works. What is the real world impact? Well, this approach helps identify the reasons for defective products. It helps uncover causes of production delays. It helps resolve equipment failures. It helps improve worker safety. The overall impact is reduced downtime, improved efficiency, higher quality products, safer workplaces. This is how science solves real problems in manufacturing. This is how science improves industry. Let's summarize what we have learned in this lesson. We learned that quality control ensures that products are safe and reliable. We learned that manufacturers don't just hope products are safe, they test them, they measure them, they verify that they meet standards. Process optimization improves manufacturing efficiency. Manufacturers don't just accept the way things are, they test improvements, they measure results, they implement changes that work. We also learned that problem solving in manufacturing uses scientific methods. When problems occur, manufacturers investigate, they gather evidence, they identify root causes, they test solutions, they verify that solutions work. We also learned that science improves industry and protects consumers. Every product you use has been tested. Every product has been checked for safety. Every product has been manufactured using scientific methods. Now, before we move on to lesson 4 of focal area 3, I want you to think about these reflection questions. 1. How does quality control protect consumers? So, what would happen if manufacturers did not test products? 2. Why do manufacturers test products? What could go wrong if they did not? 3. What could go wrong if they did not? 4. What could go wrong if they did not? 5. What could go wrong if they did not? 6. What could go wrong if they did not? 7. What could go wrong if they did not? 8. What could go wrong if they did not? 9. What could go wrong if they did not? 10. What could go wrong if they did not? 11. What could go wrong if they did not? 12. What could go wrong if they did not? 13. What could go wrong if they did not? 14. What could go wrong if they did not? 15. What could go wrong if they did not? 16. What could go wrong if they did not? 17. What could go wrong if they did not? 18. What could go wrong if they did not? 19. What could go wrong if they did not? 20. What could go wrong if they did not? 21. What could go wrong if they did not? 22. What could go wrong if they did not? 23. What could go wrong if they did not? 24. What could go wrong if they And 3, how does scientific thinking improve manufacturing? Think about efficiency and safety. In Lesson 4 of Focal Area 3, we will learn about how science is applied in education. We will see how teachers use scientific thinking to help students learn. So get ready for Lesson 4.